live so far as I can tell. Yay, excellent. Okay, hopefully everyone can see me, hear me. According to Google, everyone can see me and hear me. So I'm going to assume that that's the case. I've got the chat window there on that screen. I've got the Hangout window here. And I'm going to soon switch that over to do a screen share so that you can see my screen and I can do all sorts of live coding. Anyway, welcome everyone to this webinar on regular expressions. I'm really glad that you guys were all able to join me. I'm doing these, for those of you who don't know, actually, I guess, I assume most of you know, but I'll just give a tiny bit of background for those of you who don't. So I've been a consultant for about 20 years. I mostly now do training in Python, Postgres, Git, and Ruby. I wrote a book, Practice Makes Python, which I think a bunch of people here have bought, maybe even read. And so I use these both sort of see what people are interested in, get good feedback and questions, sometimes experiment with new courses that I'm working on. And next week, 2 weeks from now, I'm going to be starting a course with a company teaching regular expressions, and I've taught them before. This is sort of a new standalone course. And in part because much of the reason for doing this as a separate course is I used to include it in my basic Python course and my basic Ruby course for that matter. And that just pushed aside because there wasn't enough time to deal with it among the other things. And so then I put into my advanced courses, and there wasn't really enough time for that. Because basically I found that even experienced developers, basically find it really hard to understand regular expressions. And so basically, I decided to break it out. I'm giving it as a 2-day course at Cisco. I'll just say the name. It's at Cisco. And hopefully this will, I'll be able to do it more both online, different companies, and I may even do a book out of that as well. We'll see. So I'm definitely interested in hearing people's pain points, what they do understand, don't understand. I'm going to assume, for the purposes of this webinar, that you guys all have some programming experience. I'm going to use Python for most of my examples, but we'll look at a few other forms of regular expressions just sort of for comparison's sake and to see where you might be able to use some things. And we'll see how much we get through. I've slated about an hour for this webinar. And if we get to super advanced stuff, I'll be surprised. But hey, there's always next month, right? Okay, so let's actually start here. I'm gonna do a screen share here. I often try to have slides, but I just don't. I think we're just gonna do lots of live coding. So let's see. I'm gonna do a screen share. We're gonna choose screen number 1, which is that one. Yes, I think so. Click. Oh, I have to do it share. All right, now I move. Okay, now we got the infinite window. Sorry about that. So I'm going to wait. Screen sharing. So you should now see, yes, that's exactly what you see. Excellent, excellent, excellent. All right, I'm going to fire up IPython here. I'm going to make that a little bigger, even though that is such a beautiful view of something in somewhere. California, I think. Okay, and then, so you can see my face, let's bring up Photobooth. This was an idea that someone had a few months ago on the webinar to use Photobooth to basically make it a little more personable. That's me. Hello. All right. Cannot make that window any smaller, so we'll just move me a little bit over to the side there so we get a little more space on our terminal. I'll probably play with Emacs a little bit as well. Okay, actually, let me just bring that up because I do have a few notes there for myself. Yeah, excellent. Okay, so let's start off with some basic stuff. What is this regular expression thing? And I'll tell you how I learned about them. Oh, I'm covering the window, right? I'll tell you how I learned about them. So many of you know I went to MIT undergraduate, and I got there in the fall of 1988. And I had actually had a tiny bit of experience with Unix and with Emacs before getting there. But basically within a week or two of arriving there, everyone's told you need to learn Emacs. Everyone's told you need to learn Unix, and we're learning it. And I encountered in the Emacs manual, because that's what all new students at the university do. They read the manuals of the software they're using. And they mentioned this thing called regular expressions. And I was like, huh, this sounds really powerful. And I basically read through the manual on it, and I said, I have no idea what they're talking about. This is just completely impossible to understand. I'm sure it's useful for some people some of the times, but it's probably so esoteric, who really needs it? And of course, the joke was on me because 4 years later, when I was working on my undergraduate thesis, The story is I went to a bookstore. Remember those bookstores? And I bought a book on Set and Awk, and I bought a book on Perl. And I read the book on Set and Awk. I said, huh, that's really interesting. And then I read the book on Perl. And I said, why did I buy that first book? I can just do everything in Perl that I did there. And several people have said over the years that for many, many people, including myself, Perl was the catalyst for learning regular expressions, because you cannot program in Perl without regular expressions. It's basically impossible to use language without them. And slowly but surely, I began to recognize how useful they were, how useful this pattern language is for describing different kinds of text. I'm assuming you guys are seeing me. I see someone's asking here. I'm on. Hope you guys are. And I didn't realize that there's like a 15-second delay, so I probably just answered it after someone else did. And anyway, and over the years then, both using Perl and then starting to work with databases, starting to work with text processing of all sorts, I really started to appreciate the power, I don't know if elegance is the right word, but the terseness and the simplicity of regular expressions. But they are not easy to write, especially when you get into hairy situations. They're very, very, not live. Oh, you're not live. Oh my goodness, you're not seeing it. Uh-oh. Is anyone seeing me? Now this is interesting. It seems that not everyone is seeing me. I'm gonna, it says stop rather, present to everyone. I'm screen sharing. Let's see. Can I get to a chat window here? This is always so exciting. Oh, but can people chat? Oh, this is so frustrating. If people, oh, goodness gracious. That is in, let's see what. Let's see. Let's stop the screen sharing for a moment. Let's see, where am I? 2 links. Let's see. Well, that seems working. Are people seeing me? Are people? I'll be able to see the YouTube. Okay. Sorry about. Okay. Get that with the chat. Thanks. All right. Okay. Okay. People are getting. No. Okay. Oh my goodness! What a mess. All right. There we go. Oh. Well, folks, gotta love technology, huh? Okay. Okay. So let's try this again. So, all right. I'm gonna try this again then. Okay. So I'm going to assume that people are now seeing me. I'm going to start over a bit. I apologize if some of you are getting a repeat. And then those of you who are watching at home on the YouTube recording after this actually happened, sorry. So I'll go through. So basically, I've been using regular expressions for over 25 years. Perl was really the catalyst for me to be able to use regular expressions, or to learn to use regular expressions. They are short, they are terse, they are powerful, they're really hard to write, and they're even harder to read. And I find that a lot of people are challenged when they're using regular expressions because of this bizarre syntax. And you have to remember also that regular expressions are a language in and of themselves. So yes, they live within Perl, they live within Python, they live within JavaScript and Ruby, and even in the Unix shell and various programs. But we're talking about a totally separate language. So once you learn regular expressions in, say, Perl, you can apply that same knowledge to Python, JavaScript, Ruby, Java, C#, whatever you want, which is good. Oh, I see people are actually able to see it now, which is excellent. Sorry about those technical problems, folks. And so what I want to do here is I'm going to assume you all have programming backgrounds of various sorts. Obviously, there are going to be different levels here. I'm going to assume that you have very little, if any, experience with regular expressions. And we're going to go through some explanations of at least the basics, try to see what are these things, how do they work, how do they integrate with the rest of our code. And I'm going to use Python for most of my examples and demos, but I'm going to try to demo with a few other technologies as well, a few other programming languages as well. So I'm now going to try to share my screen. I did this once before, but well, and once again, the infinite thing. Did this once before, but no one could actually see it, so it didn't really matter. Okay, so hopefully now everyone can see my screen. And now here, let's actually just shrink this window so I don't cover myself quite so much. Okay, so let's start with like the really basic things. So regular expressions here, let's try this in Python. So I've got IPython open here. So let's say I have a string ABC, and I'm interested, is the letter B in the string? Well, in Python, there are a few different ways for me to do this. One is to say B in S, and that's just going to return me a true or false value. Is it there? Is it not there? And I can also say, something like S index of B. Or if I'm interested, I can also say in S find of B. And that's going to return me the index where it is, because indeed S of 1 is going to return me a B. Okay, so far so good. And for many people at the beginning, that's just like, that's fine. That's good enough. But then you get into sort of more complex things. So let's say I'm interested here. Let's do something like this. Dinner was served. Let's do S equals dinner was served at, let's say, 15:30. Right? So that's a time in obviously 24-hour time. So now I want to find out if there's a time in that. Well, now I'm sort of stuck, right? Because now what I'm doing is I'm saying, like, as a person, I can say, is there a time in that string? But telling the computer, I want you to find a time, we have to define what a time is. And the time is actually inside of a string. And so I can't really say, like, is 1, 1 in S, right? Because that will be true. But it would also be true, T equals 1, 2, 3, 4, 5, right? If 1 is also in T. So I need a richer language than just this in or even a find. So I can say, I want to look for a certain pattern of text inside of there. And regular expressions are basically a fancy way of doing this a fancy way of searching for patterns inside of text strings. Now, regular expressions, the term regular expression is actually a mathematical one, and one that I don't understand all that deeply. And it turns out that the regular expressions we use in most modern programming languages do not fit the definition of regular expressions. Because they have what's known as back referencing, where you can find something and refer back to what you found. But everyone just calls them regular expressions, or we also call them regexps, which is, of course, so easy to pronounce. But that's what we call them. Okay, so let's say I'm in Python here. I want to start using regular expressions. Well, the first thing I have to do is say import RE. And RE, not surprisingly, is the regular expression module that comes with Python. And so it's via this RE module that we're able to do all of our amazing stuff with regular expressions. The other interesting thing, and here Python is different from many other languages, not all but many, especially say Perl, Ruby, JavaScript. Regular expressions in Python are objects, but they're handled as strings, right? In these other languages, we sort of use slashes to delineate where we have regular expressions, and it becomes a regular expression object. So in Python, I can create a list object with square brackets. I can create a tuple object with parentheses and commas. I can create a dictionary object or a set object with curly braces and with or without the colons. But there's no such thing as creating a regular expression object with funny syntax. Like we sort of ran out of delimiters. So we have to use the RE module, and we hand various methods within the RE module a string, and that string is turned into a regular expression object, which we can then use for searching and matching. Okay, so that's fine. So let's say now I have my string, and let's actually keep that string because that could be fun. And we know already that I can search for a 1 inside of there. Okay. What if I want to search though? Well, let's say I use my regular expression engine. I'm going to say here re search, and I'm going to say I'm going to search in S for 1. Oh, sorry. Huh. Oh, I always get it wrong. Hold on. Re search. Yeah, I actually have to do it. Yeah, it's the pattern. Re search. I'm going to search for 1 in S. Much better. And I get back, oh my God, I get back a match object. And this match object is basically Python's way of saying, I have information for you. And traditionally, we're going to say m equals this re search. And okay, so if it found a match, what do I do with this match object? Well, the easiest thing to do is ask it for group 0. Group 0. We're not going to talk about groups today, or we're almost certainly not going to talk about groups. Don't worry about it. So I'm just going to say m.group 0, and it's going to find, what do you know? I searched for 1 inside of S, and it found 1. And where did it put it? It put it in this group 0. I realize that this seems a little strange. It becomes a little more reasonable as you work with it over time, but we'll see that there's some ways to get around this. Now, what is this re search? Oh, help is great. What is re search? Re search is, it's a search as a function inside of the re package, inside the re module, and it looks for our regular expression, our pattern here, inside the string, anywhere in the string. So I can also say, and so we see here, like the 1 was deep inside of S. There's a similar function called match, re match. And now if I say, well, what's m? M group 0, you know what we're going to get? We're going to get an error message. None type has no attribute group. What the heck is going on here? Well, this is the thing. Re search looks anywhere in the string. Re match looks at the beginning of the string. So if the string were to begin with the 1, then we would get back a match object, and then we could use group 0 on it. But because re match did not find anything at the beginning, did not find a 1 at the beginning, it actually returns a none object. And none, this is why we're getting this error message, none type has no attribute group, because we're trying to apply a method to an object that doesn't have it. So what's very typical to do is something like this. M equals re match 1 in S. And then if m, we say print m group 0. And so if we do that, okay, we see here that didn't work, right? But if I say re search, we can do the same thing, and now we do see that it is there. Now this is like the simplest possible kind of searching we could do, and it seems like a heck of a lot of overhead for us just to search there. It would be nice if there were an easier way to search. Now, truth be told, in programs, you're probably going to want to use re match and re search. I happen to prefer search because I want to look anywhere in there, and if I want to anchor the search to the beginning or the end of the string, there are better ways to do it as far as I'm concerned. But if you're looking at the beginning of the string, you can always use re match. But when I'm working interactively, or when I'm playing with a regular expression and trying to get it to work or see if it's going to work, I don't use either of these. I actually use re find all. And re find all, instead of returning a match object or instead of returning none, it's just going to return everything it finds that matches. Meaning I say now 1 in S, and it returns a list. Re find all will always return a list. It might be an empty list, right? If I say find me zzz, it'll return a list, but it's a list of 0 times that it found anything. So when I'm teaching regular expressions, I really like to use re find all because it gives us an easier to use interface to find things. And if our match matches more than one thing, we'll see that right away in a list of multiple elements. Okay, so we're going to use re find all. By the way, re find all in Python 3 returns an iterator, like most things in Python 3 that return lists in Python 2. I'm just using Python 2 here. Most people I work with prefer it. But you can play along at home if you want to use find all. Just realize that you're not going to get a list back. You have to put a list around it to force it to be a list. Okay, so great. So I found a 1 in S. Really? Did I need all that overhead just to find the number 1? That seems a little extreme. Well, that's because in regular expressions, most characters match themselves. And so for the most part, not that we're going to use it this way, but for the most part, when I'm searching for regular expression, I could be searching just for a regular string. So if this is my string here, I can say re find all, and I can say find me, inner. And it returned, oh, sorry, inner in S. Right, and it found 1 instance of inner. Okay, and I can also say find me all e's. And here we go. There were 3 e's in there. Well, we also see that some of those e's were followed by r's. I can say find all times that you see e followed by r. And find me all times that you see e followed by d. So we have the ER from dinner, we have the ER from served, and then we have the ED from served as well. So here's what I'm going to do. I'm going to say to Python, listen, I want to find E anything. And this is where we're going to encounter our first meta character, right? And meta characters, this is where I have to put in the obligatory joke, right? I never met a character I didn't like. Brilliant, I know. Anyway, so here's what I'm going to do. I'm going to say to Python, listen, I want to find E, and then I want to find whatever is after E. And so I can't say whatever is after with a regular character. I have to use a meta character. And our first meta character then is going to be dot, a period. And period matches anything other than new line. That's the definition in Python. So now when I say find all E period, it finds me ER and ED. It has gone through the string. By the way, if I were to use search or match, this would also work, but I would only get the first one. Those stop after search and match stop after the first match they find. find all goes through the whole string and looks for everything that matches. Again, I find this to be easier both when playing with regular expressions and debugging them and also teaching people. Okay, so you can see here E dot. Fantastic. You know what, let's modify our string a little bit. Let's try something like this. Oh, I'm trying to think. I don't know. Period. Fine. That's really lame, but fine. And now I'm going to do my find all again. Well, look at that. We found, that was exactly the wrong thing to do. I don't know. A, B, C, D, E. That's really lame. Yeah, but okay. So now you can see here that what do we match? We matched ER, ED, and E period. So period, now we have to remember though that the period here, the dot here, is a meta character. It's saying I will match any character other than new line. Here, this is an actual period. So period match period, but just because this meta character is very general. What if I only want to match an actual period? Well, that's very easy. Then I have to use a backslash. And the backslash says I want to keep that neutral, right? I want to neutralize the meta character and turn it back into a regular character. Okay, sounds good so far. Let's do something like this. I'm now going to open up a second terminal window. Let's make the text here a little bigger. Oh, I see. Now it's going to be like this floppy thing with like different sizes. Okay, fine. We're going to don't want to like make my face disappear too much. All right, and so now I'm going to take this text and I'm going to put it into a text file. So cat test.txt. Here we're going to paste that text. Great. Now you may remember or know that there's a Unix program. I'm just going to make this a little smaller so I don't block myself. A Unix program known as grep. And grep is supposedly short for Global Regular Expression Print. And the rumor is, I've never actually tried it, but the rumor is that in the said stream editor program, use G/RE/P. And the G means global. The RE stands for regular expressions like a variable, and P means to print. But grep is just a fantastic, fantastic program. You know what, I'm actually going to like add to that file there just to make it a little more interesting. This is also a line of text. Okay, now grep allows me to search with regular expressions. So I can say grep, let's say E in test.txt. And look what's going to happen. It's going to find me all of the lines in which E exists. And you see this modern version of grep even highlights it in color. That's pretty snazzy. Well, what if I look for E dot? E dot test.txt. Look at that. Once again, it's going to find ER, ED, and E period. Once again, dot is a meta character. And this is where knowing regular expressions is really handy because you can be working on many different languages and technologies, but if you know regular expressions, you can use it in all of them. And that part of your code will stay the same. How you apply them and what methods exist in the language can vary, but this works just fine. So, okay, so we found, E dot, and that means E different things. And if I say here E backslash, right, same thing exactly. And we see that the second line now does not appear in our grep output because it does not have an E dot. By the way, grep has a lot of options. But I can say here grep minus little v. And minus little v means flop it. Wherever on any line that it might match, don't show. And the lines on which it does match, don't show the ones where it does match and do show the ones where it doesn't match. I think I got that right. Okay, so grep, use it all the time. So here's an example. Let's look at the programs for my latest Python course. I do an ls minus l. Whew, that's a lot of things. A lot of programs in my Okay, I think I'm back on. Okay, wow. Google really hates me, or someone really hates me. Okay, I'm going to go back to the screen share. There we go, share. Okay, so anyway, when we before I was so rudely interrupted by a large international corporation, basically my plan was to take this list of files, and now I want to look for all the files that were done sometime in January, January between January 10th and January 19th. Okay, so what do? I can say ls minus l. I can say grep. I can say, well, June, let's say June space 1 dot something. And now, sure enough, what's it going to do? It's going to look for every line. And it's not only looking in that column, right? Let's not get so fancy yet. Anywhere that has June space 1 dot, right? And you can see here, this is where it finds things. So if I want to find all the things from June 16th, right, obviously I can use grep for that. And why does grep work here? Because I'm not using any meta characters. I'm just saying plain old characters. Okay, I'm glad people are seeing it and hearing it. Okay, so that's our like brief tour into meta characters, and you can see that these regular expressions work in different things, or are starting meta characters. Okay, well that's kind of fun and that's kind of nice. Let's see. Let's try something else here. Let's try it within Python. I'm now going to open up. Here, let's do open. Well, you might know the user share, at least on my Mac, dict words. Okay, and if I read that, right, I'm going to get a huge. Let's like limit that to 20 here. Right. So I'm going to get a long list of. Oh, that's not exactly what I want to do. I want to do a split, and let's get that up to 20. Sorry. Here we go. I have the first 20 words in the dictionary now. So what did I do? I opened the file words. I read it into memory. I split it on white space. And And then I just took the first 20 items from there. Okay, well, here's what I want to do. I want to take all of the words here that have 4 letters in them. Well, how am I going to do that? Well, actually, let's do 4 letters that begins with A and ends with E. Well, there are a few different ways to do that, but let's just do like the simple way. I'm going to read this all into memory. By the way, if your computer does not have a lot of memory, you probably don't want to do this because it could take a lot of time and memory and so forth. So if I read it, I'm going to get a really long string, and I'm going to say RE find all. And what is my pattern going to be? Well, I want to have, I said, 4 characters in the word. So it could actually be ... right? But I want to say it starts with a little a and ends with a little e. And let's see what we're going to get. Okay, and find all we know always returns a list. So I'm only going to do this up to, like, let's say 20 words. And here we go. I have, well, it's not exactly 20 words, is it? Right, because find all, as far as it's concerned, it's going through this string. It's saying, found A something something E, right? This says, and it, by the way, it cannot be A B E or A C E. I mean, it could be, but there has to be 4 characters going to specified 4, starts with A, ends with E. But I didn't say that has to be the beginning and end of a word. All I did was I said, well, it has to be A and E. And there are ways to specify the beginning and ending of words. Oh, the file to work on? Your computer, probably if you're using Linux or a Mac, you almost certainly have a dictionary you can play with. If not, you can just write a small text file. This is where it is on my Mac. I think it's like often in a similar place on Unix, or Linux, I should say. So let's say I want to now find only words that begin and end with this. Well, I can say space, A ... E, space. And now look what I'm going to find. Nothing. So I guess there aren't any such words. Well, this is where things get a little weird. We can do that. Do, right? Maybe there are no such words, although not 20. Well, let's try this. What if we do it here? And part of the problem here is that we are telling our regular expression engine, I want you to find a space, then A something something E space. What if I say here like A dot E? Well, that's a little weird actually. Find all. To do that. Huh, I'm actually a little surprised. Okay. Fine, be that way. What if this is where testing can help in advance of actually trying something. But if I say here, I ate a sandwich and and we are now happy. Right, so if I search for in there, oh, see, that worked, right? All right, and you can see that now this is another important point. The space characters are significant. They are characters. So if I were to say here, dot A dot E dot, look, I get the same results because here the dot is any character other than new line. All right, and so you can do a lot with these dots. But that's not enough, right? There are many cases in which we want to do something a little more sophisticated, and so we have other meta characters. Now, dot is a meta character in that it doesn't only match itself. That's where the definition of a meta character. But we have others that modify how many of each thing we're going to have. So I can say, let's try our dictionary again. Hopefully this time it'll work a little better, right? And so I'm going to open it up. I'm going to read it, and I'm going to look for. Let's look for S. Watch this. SE plus. What is plus? Plus is a meta character, and it modifies whatever comes before it, meaning the E. The plus here does not affect the S at all. It just modifies the E. And it says, I will allow that E to appear one time or more than one time. How many times? Who knows? Could be a billion times, although that would be a really long dictionary, so probably not. And so now when I do that, if I say find it, look what I found. I see SE and SEE. And in theory, if I have SEE, right, it would do that too. And I just have this long, long, long list now of SEs from my dictionary. Okay, and I can say, SEEN. By the way, one nice trick that I sometimes do, just to find the differences, is I then put this all into a set. And then we find all the different things that Python has found. So we see here we have an SE plus N. So that means S must appear once, E any number of times, but must be at least once, and then N. And sure enough, these are the 2 options that we can come up with, that Python comes up with. Okay, well, what if I say here S dot plus N? What in the world is going on there? I said S dot plus N. So I said S, any character, one or more times, and then N. So that's what it did. It said S, any number of characters, one or more times than N. So we know it's going to start with S. We know it's going to end with N. We have no idea what's going to be inside. And notice then, there's a big difference between saying SE plus N and S dot plus N. SE plus N means one or more E's. We're very explicit, E for explicit. The dot here means any character other than new line. And in some ways, it's stopping here when it hits the next word. So you have to, this is where regular expressions start to get a little tricky. Okay, but this allows me to do all sorts of things. So for example, let's take, let's take my Linux journal column, one of the more recent ones. Let's do, let's just say F equals open. You'll know where I store these things, right? Big surprise, Reuven. Text, Websmith, which is the name of the magazine that I worked on before Linux journal like folded that new venture 20 years ago. CGI column, I don't know, 200. Okay, so read. Let's just say text equals that. Okay, so now I've got my text in here. Okay, if we look at the text, boom, there's my column. I want to find the text. So here's something I do. I learn to type in a typewriter. And when you learn to type in a typewriter, you learn that after a period, you need 2 spaces. Okay, so I want to find out where do I have 2 spaces? Well, one way to do that would be to say RE find all, and let's say here /dot space space, right? And that'll find me a whole lot of places where I have dot space space. Notice, by the way, it's not telling me where these things are. The point of a regular expression is often not telling me where. It's to find the text. It's doing the match. You can get that information if you have a match object. So if I were to do here an RE match, M equals that, right? So M group 0 is going to give me, oh, I'm sorry. Oh, because I did search. I need to search. Sorry. M group 0 will say, well, dot space space. Fine. But if I say M, start, and M end, look at that. It tells us from 137 to 140. Meaning in my text, I can say here, the text from 137 to 140. You know what we're going to find? Voila, dot space space. So the match object does tell us where we're going to find this. And that's information that we lose if we use find all. All right, but that's not that interesting, right? What I'm interested actually is, find me where I have, where did I put this here? Let's just do it this way, RE. Yeah, find all, that's what I wanted. All right, so this is going to find all of them, but let's not look for 2 spaces. Let's look for 2 or more spaces. Well, how can we do that? Well, 2 or more, we can say space, space plus. What are we looking for here? We're saying, Python, tell me where there is a dot, literal dot, because we're backslashing the meta character, a space, and then 1 or more spaces. Oh, look at that. And now we see there's actually a place here with 3. In fact, if I put this in a set, yeah, we have some with 2 and some with 3. And if I say even, and this is where the integration with the rest of Python comes in handy, I can say from collections import counter. And then I can say not a set, but I can say counter for this. And it'll tell me that there's only 1 place where I have 3 spaces after the dot, but there's 36 places where I have 2 spaces after the dot. Right? So this is where I can start to degrade. Excuse me, just a moment. I have to turn on the ceiling fan. It's getting a little hot in here. Sorry, guys. Regular expressions make us all hot under the collar, as it were. Okay. So you're starting to see, I hope, some of the flexibility, but also why it's really hard to read these things, right? If you were to come into a program and see this, you'd be like, whoa, slow down. And it often takes even people who are experienced a little bit of time to say, okay, what is this doing? And I often try to walk through and say, all right, we're starting with, we're seeing this, we're seeing this. And by using find all, I can play with a regular expression and see what it's doing. Okay, well, that's nice. I can also say, well, show me all the words. Let's try this. RE, find all. And I'm going to ask for all the words. I'm going to start with a space. Let's start with A. And then let's say have, a letter or anything, right? And then let's say E 1 or more times and S. Let's even say ... of that. Oh, nothing. Yeah, I was too optimistic there. Okay, fine, folks. Fine, 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 fine. Oh, that's now what's going on here? You know what? This is actually a very important thing. I'm here saying I want to find a space, a dot plus s space. So you might think that it's only going to look in words, but that's not the case. And that's because plus is greedy. Plus says, I'm going to keep on going until I don't find a match anymore. So it's going to just keep going, 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 going until it finds something. And you can see then it's really like looking for a long time, and it gives us much more than words back. And this is a very difficult thing for people to remember, and it's a big mistake that people make when they're writing their radio expressions. Plus, if you say here, a dot plus s, well, what is it going to do? It's going to keep taking text until it can't find something that matches anymore, meaning that dot is really going to give us the trouble. And remember, dot matches everything but new line. So really, I'm guessing it's going to be a till the end of the line in almost all of these cases. Or a till the end of the line, that sort of backtracks and says, okay, this is the last S and space that we have there. And there are ways to modify that, but I don't think we're going to get into that today. But we also have something else that's similar to plus. We also have star. And star is just like plus, except instead of matching one or more times, it matches 0 or more times. Now, why would you care about that, right? Like, it seems very strange at first that you'd be looking for something 0 or more times. Well, let's think about it this way. Here, let's try this. If I say here, text equals ABC space DEF space space GHI space space JKL, just like that. All right, so now I'm going to say RE find all, and I'm going to say here dot space plus space dot in text. All right, and so what we're finding here is the end of each word and the beginning of the next word. So I find here, and I have F and G. Oh, I should have had the extra space in there, sorry. Debugging these things can be tough, folks. Right, so here we have CD, right, the end of one, the beginning of the next. I have F and G, I have I and J, and it'll just take, because it's plus, it'll take any number of them, and that works really nicely. Well, there are times when I might not have something there. So let's see, if I want to say, oh, here's an example. Let's say I have A, let's do this. Yeah, RE find all, that's my text, is A space B. Okay, and I can say RE find all, A space star B of text. And that's going to work. It's going to find A space B, because I'm saying here A space 0 more times than B. It'll also find it if my text, let's change the text a little bit, has lots of spaces. Then same thing. Oops, there we go. But it'll also work if my text is just A and B. Why? Because the star means 0 or more times. The star can be a little tricky. It will always match because it can match 0 times. So if I say here A QB, actually it'll still work. And that's because the Q, well, it found a Q 0 times, and that's okay too. So already, just with this dot and plus and star, we can start to see, this is very similar, by the way, for people who are used to working in the shell, Unix shell, right? You've seen star, you've seen question mark, you can use wildcards to sort of identify patterns in the file names. But this goes way beyond that. I want to show you a few more examples of things and see where we can sort of go with this. Okay. So let's see. So we've got now, yeah, let's say we have now, watch this, numbers equals, just a string them. All right, and let's say, 100, 100 and I want to get all the numbers out of here. Well, here's one way to do it. I can say find, RE find all. I'm going to say here 1, 0, star in numbers. And look what I get. I get, because I said here, 0 has to appear 1 or more times, 0 or more times. So we get 1 followed by any number of 0. So the 1 still happens, but so is, what is this, 100,000, a million, something like that. 10 million. What's a few orders of magnitude among friends? So I hope you're starting to see that like the star can be useful, but you have to use it very, very carefully. I sometimes use it like if I'm looking for white space between things. So if I'm looking for, like if I say here, text equals ABC, EF, right? And so I'm looking for, perhaps not the best example, if I say RE find all of, AB, well, let's look for. All right. Well, anyway, I was going to say we don't quite have the tools to do it yet, but sometimes you want to look for things they might or might not have space between them. All right. We'll get to that maybe later or maybe next month with the webinar. Okay. So we've got dot, we've got plus, we've got star. Let's look for something a little more sophisticated that I love to use and which opens the door to lots of possibilities, and that is character classes. So let's think again about our dictionary. And so I want to find, let's say, all the three-letter words in the dictionary that start with A and end with a D and have two letters in the middle. All right, let's see if we can do that now. Find all, or RE, find all. And we're going to say here, our pattern is going to be A dot dot, but I say D. Right? And we're going to say this is going to be an open user local share words. Share local words. User share dict words. User find all. Let's look for this again. A dot dot D. And let's actually. It helps to actually read things. There we go. And look at that. We found and here. Sorry, let's put this into a set. And we see lots of different things, right? So we have A something D. Well, I actually wanted two things there. A dot dot D. Finally, we found that. And now let's find, put a space at the beginning there. Oh, now it's not going to find it. Okay, fine. Okay, so it won't find it. So I'll just do this. What if I want here, find not just D at the end, but maybe N or D at the end? Well, my favorite way to do that is to have a character class. A character class looks like this. We open the square brackets, and then we say here N or D. And this is an or. It means one of these two characters must appear. And now we see that sure enough, we have A, something, and either N or D. That's pretty good. I'm telling you, folks, I use this all the time. This is one of my favorite parts of regular expressions. It can lead to them being a little hard to read sometimes, but it makes things like great. So for instance, let's go back to our file system here. Right? So I want to find all the things that were, let's say from, okay, let's make it like this. So before I had one dot, and it was everything from June 1 something. What if I want either 1 or 0 there? Well, I could say 1, 0. Let's say we are 1, and then a dot. Actually, it's not going to be 0. It's going to have space or a dot. And sure enough, that's what I get. Right? Because it's looking for June, space, and then either a space or 1. Right? So that gives me the sort of flexibility that I want in order to search for things. Now, I use character classes, I'm telling you, all the time. If I want to look for here, big letters or small letters, right? So I want to find all the words here that have, like, let's say, either a big A or a little a at the beginning, and let's say B, and let's say a vowel, A, E, I, O, U. Say in, now I have to get that back. Here we go. Okay, open. We're going to read that. And look at all these different things that we found, right? Because it's either big A or little a, followed by a B, followed by a vowel. Now, it does get a little complex, as I said, to read this sort of thing, because you have to say, okay, what am I looking for? One of these and one of these. It gets even more complicated and harder to read and harder to understand when you then say a plus here. Now, what is the plus going to do? Plus means whatever comes before it, one or more times. But again, it does not mean the thing that it plucked out of the character class AIU. It means it's going to go back to the character class and try again. So you'll see here, wow, we have a lot of results here, because what's it doing? It's saying, okay, I have either big A or little a, fine. I have a little b, fine. And now I'm going to say, do I have AIOU? I do. Do I have another A-I-O-U? Like, it's going to keep looking. So we have all these words that are, I'm sure, excellent for great Scrabble players, and I should probably pay more attention to for my Scrabble playing. But they are in there. I can even then say, of course, right? And then I want to say, I don't know, D. It's going to find, oh, actually write the letter when you're searching for it. D. Right? And now it's going to find A, big or little, followed by a little b, followed by a vowel, any vowel, one or more times, followed by a d. And this is the sort of pattern matching that makes regular expressions so incredibly powerful. Right? So I can look through, if I'm looking through words, if I'm looking through text, if I'm looking through usernames, if I'm looking through IP addresses, I can really start to look. Now, some of these comparisons and some of these sorts of searches are so common that Python predefines, Python most regular expressions, I should add, let me give you a little historical note. So as I mentioned earlier, that might or might not have been recorded, might or might not have been viewed by you folks. Perl was really the first language to mandate that programmers understand regular expressions in order to use it. Before that, you could, but you could also ignore it. But in Perl, you need to know regular expressions. And Perl's regular expressions got more and more powerful over time. And they added all sorts of things to the regular expression library that were not elsewhere. And there's now a library called PCRE for Perl compatible regular expressions. And many, many languages and systems will say we are or are not compatible with Perl, or we use or don't use PCRE. And Python does not use, as far as I know, PCRE, this library, but it does try to be compatible with Perl regular expressions. That includes a whole lot of different features that we're definitely not going to get into tonight. But one of them is, and I don't know if this was defined with Perl, although I think it was, character classes for common things. For example, let's say I want to find a word. It's very common to look for letters, numbers, and underscore. So they define a character class \W. \W means a word character. And now I can explain to you using regular expressions. It's A through Z. And yes, you can use a hyphen in there. A through Z big, 0 through 9, and underscore. By the way, this raises the question, if you can use a hyphen in there and it knows that's not like an actual minus character, then how the heck do you put a minus character in there? And the answer is at the beginning or the end. So \W is that, and \big W is everything that's not that. So A to Z, 0 to 9. And you know how we say we want to negate this character class? I put a caret at the front. And this means everything that's not that. So already we can say, okay, well, I want to find then, let's do this. Let's go back to our set, already find all. I'm going to say now, I want to find a \w plus D. And now let's limit this to 20. Well, what's it going to do? It's looking for all the words that begin with a big or a little a, and then have one or more characters, at least one character, at least one letter. So it can't be a space character followed by D, meaning words that begin with A and end with D. That's what I've described here. Now, in theory, if there's a period in the middle, that will also appear. I'm sorry, not period, but there's an underscore in the middle or a number in the middle, it will also appear because those also match. So if you didn't like that, if you said, no, I don't want to have numbers, underscores, you could say A through Z, right? And that would basically give you the same thing. Letters as well, maybe. And we could, of course, say, well, actually, I don't want to have any of those. I want no letters followed by D, in which case, yeah, what have we found? We've found new lines, A, new line, AD. Not exactly common words to find in here. I think I'm going to turn to questions in a few moments. So if you guys have questions, you start putting in the chat. I just want to show one or two more things here with these built-in character classes, and then I'll answer questions, and then we can, I think, call it a night for those of us for whom it's night. For those of you for whom it's morning, you can call it a night for me, or morning for me. Anyway, I'm punchy this late. Sorry. So these built-in character classes are super useful. What's another one? Well, \S. \S is all white space, and that means space, tab, new line, carriage return. So this is great. It means I can search for not spaces between things, but any white space between things. So if I have here S equals ABC space tab EF, and now I say re find all, and I just want to say, we'll show, let's find all. Sorry, actually redefine this a little bit. Space, 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 tab, 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 GHI. I say re find all, and I say here \w \s plus \w. Helps to put that in a string in S. What am I going to get? Well, look at this. I get C and D with all that white space in the middle, or F and G with all the white space in the middle. Now, we're not going to have time to talk about what's called re replace, but I could, well, I'll just show it to you. Actually, oh, what the heck. Re replace. And re replace says, I'm going to look for, let's say, \s plus, which means one or more white space characters. And what am I going to replace them with? Well, in S, replace them with a space. Oh, sorry. Re. Re. What's it called? Sub. Sorry, folks. Double checking. Sub. Oh, sorry. And we need to flop that around. There we go. Look what I've done here. And this is something that I've definitely done a lot in the past. Re sub says, look for this regular expression. And every time you find it, substitute it with this and give us a new string back. So I've now taken all these things and I've said, oh, let's remove all the white space and turn it into just space characters. Now, I want to warn you that some of these things, like what we did so far with these meta characters, should work in everything except for character classes, which sometimes in certain versions of the regular expression engine, you actually will need to backslash. So instead of square brackets, you have to say \, square brackets, which is really, really annoying. Okay, I think we've covered some of the basics here, and that's all I sort of intended to do. If there are questions, I'd be happy to answer them. If not, I'll just give like one more example of something which I think would be fun, and then we'll call it a night, and we'll do this again next month. So let's see, any questions from folks who are there? Are people still there? Are they all gone to breakfast or bed or lunch or whatever time it is for you folks all around the world? Here, tell you what, I'm going to show you one more. So if there are no questions, I'm going to show you one more character class and have some fun with it. So I have here a file which I call, let's just this cd into something courses Python programs. This is where I put my exercises. And if we look at, let's just do this. Open mini access log txt, read. How do you parse HTML with regexes? Ha, 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 ha. I'll tell you, that's actually a very common question that people have, and the answer is don't do it. It might even be theoretically impossible from what I've read, but even if it is possible, you almost certainly don't want to do it. What you might be able to do is take little bits of HTML and parse that. But a full HTML or XML parser, you're just not going to want to do with that, even if you could. All right, so what you can see here is I've read, let's just print this out. What you see here is like an Apache log from a number of years ago. Okay, and so in my Apache log, I have, it always starts off with the IP address and then, date information and what we're getting and so on and so forth. So, okay, so here's the thing. I want to grab the IP address from each of these. So what am I going to do? I'm going to say re find all. And well, how would we represent an IP address in regular expression language? Well, actually, it's not that hard. Once we know that, remember there's \w and \big W. And then there's \s for all white space and \big S, which means non-white space. And then we have \little d, which is a digit, and \big D, which is a non-digit. So what I can do is I can say re find all, and I want to find \d, little d, a number, plus, followed by a period, followed by another \d plus, followed by another period, followed by \d plus, followed by one last \d plus. If I do that, look what I've got. Bam! I just grabbed all the IP addresses, which is pretty pretty fantastic. And now I can go back to my counter from before, right? And now we know how many times each IP address came to our website. Not bad for one little line of code. And of course, the regular expression guarantees you job security for life because no one will figure out what it's doing. And that's the sort of task that regular expression is just fantastic at. You've got all this text that you're running over, and you want to be able to grab certain parts of it. I think if we do this again, we'll almost certainly do this again next month. I may continue sort of with the regular expression stuff from where we leave off here. But if we look at that file, actually, maybe you can think about this on your own if you're a little more experienced. Can we grab the time and the date? And the answer is yeah, you can definitely do that. You'll want to watch out for these square brackets because those are meta characters in regular expressions. So to grab them in Python, you need to use backslash before them as like to make them non-meta characters. But then all we have is numbers with slashes and numbers with colons, and you can definitely grab those and do a similar sort of counter, right? How many times did each of these appear? Now we have a question here from Marco, if I'm not mistaken, that's the name. Marco Cipriani, sorry. And so what's the meaning of the R before the pattern you want to search on? Yeah, so here's the thing. Regular expressions, as you've seen, use a lot of backslashes. And this is something that Larry Wall, who invented Perl, called backslashitis, because really in traditional Unix regular expressions and Emacs regular expressions, you use backslashes to indicate that a character is a meta character. And you don't use a backslash for it to be normal. So dot, actually I'm not sure if they do this for dot, but definitely square brackets, for instance. You use backslashes there where you don't in Perl and Python, and vice versa, which makes it very frustrating for people like me. In any event, so there are certain cases in which here, for instance, right here, I've got this backslash D. What if backslash D is actually a character, like backslash T? Right, if I use backslash T or backslash N, we know that we turn into a tab or a new line, and that would be really bad. Because we're not searching for tabs or new lines, we're searching for these meta characters, these character classes. So what you can do is you can, of course, double the backslash. And this is where Python's regular expressions get really annoying. Because what you're doing is you're doubling the backslash to undo the magic. Like Grace, I understand, you got to undo the magic. And that just gets like horrible to read, horrible to write. So what we're going to do then is we're going to say to Python, listen, everywhere you see a backslash, just double it. And that's what a raw string does. Oh, and now I see, because I had a double one here. Oh, and there too. Right, and raw strings just double them automatically, meaning that they neutralize the backslashes. As a general rule, I say to people there are two places to use raw strings, and raw string just means R at the beginning, little r at the beginning. It means any backslash is doubled. Number one is if you're on Windows, then for path names, raw strings come in handy. And the other thing is in regular expressions. Now, the things we've seen so far in the meta characters, Python knows how to deal with them. But there are certain meta characters like \1, \2, the back references, we definitely aren't going to tonight, where Python goes crazy. And if you just try to say, like, well, if you try to give it a \1, it'll probably crash on you. Or it'll just give you an error. So you need to use a raw string there. Anyway, so I hope that explains it. Any more questions from folks in the audience? Despite the incredible number of technical hurdles that I managed to put in your way in order to watch the webinar. All right, well, I'll give it a few more seconds because I know that's like a 15 or 20-second delay from the time that I say something to the time that questions come in. My impression, though, is that people are sort of out of questions for now. So I think that I'm going to wrap this up. I hope that you guys enjoyed it. I hope it was useful, gave you slightly less trepidation. I'll tell you, of course, the most famous statement ever made about regular expressions. Jamie Zawinski, JWZ as he's known, is a famous programmer. He worked on a huge number of things. He worked on a Lisp system. He worked on a version of Emacs because he hated Richard Stallman and it was mutual. And then he went to work for a small company called Netscape, where he became fabulously rich. He did a lot of work on the Netscape browser. And then he had the idea of making Netscape, turning it open source, which is the basis, of course, of Firefox today. After becoming rich and after leaving, what did he do? Well, he, of course, did what all programmers want to do, which is open up a nightclub. And so his nightclub, the DNA Lounge, runs. And anyway, he's a wacky guy. And he once said, if you have a problem and you think you're going to solve it with regular expressions, well, folks, now you have two problems. And there's a very well-known thing in regular expressions where they're really hard to read and understand. But hopefully a little less panic now. I'm glad to get good feedback from you. So we're going to end now. I would love to hear from you folks. And I will figure out a time. I'll send to the mailing list and Twitter and all those other places, let you know when and where. But thanks so much. I'm going to have to bed soon. And I'll post this on YouTube. And I will send to the Eventbrite list where the video is so you can review it at your leisure. All right. Thanks, everyone. And I'm going to stop this. And I will talk to you all soon. Bye-bye.